Hi guys, welcome back to my YouTube channel. So today I Prapulla.m from Sri Venkateshwara College of Engineering is here to explain you guys of the on the maths topic called as exploring the vector space. So in last class we learned about the rules. So in this we will be learning about vector space. So here it goes. So the first thing in this topic we are going to learn is fundamentals of vector space. So the vectors are the mathematical operation that have both magnitude and direction, allowing them to represent quantities such as velocity, force, and the position. The vector operation like addition, scalar, multiplication, and dot or cross product enables the manipulation and analysis of the vector within the vector space. So the subspace vector space can be decomposed into a smaller related subspace which aids to understand the vector conditions in this uh, fundamental. So the fundamentals are of three types. One is vector operation, and subspace. So these are the things which we learned about vector space. So the next topic would be the graphical representation, where we would learn about how the graph is made for this vector space. Graphical representation of vectors. Vector diagram. So the diagram in the left hand side we could see F1 and F2 together make a F axis where the F is equal to F1 plus F2, whereas F1 is making a small triangle, the isosceles triangle Fx and Fy is making a F1, and whereas the above one F2 is making a Fxy and Fy2, and later on we take a small part of it and name it as b. So from where we combine fx1 and fx2, and f2 can also be written, fy2 can also be written as y2 is equal to y2 x1 plus y2 x2 and xy1. So the vector visualization. Vector can be a graphical representation as an arrow within the vector length representing the magnitude, and the direction represents the origination. So these are the graphical representation of the vector space. So the vector space we learnt about the vector diagram and also a vector visualization. From this too we come to know how the vector space can be understood easily, and how can we apply and make some numerical for this question. So the next slide would be based on the topic vector fields. Vector fields are the space distribution of vector quantities such as force or velocity, allowing the visually understanding of the complex system. So, the coordinating system. Vector can be expressed in different coordinates, such as providing a unique representing the vector space. So there are two types of configuration. They are vector field and the coordinate system. So these are the two things we learned in this slide. So the next topic of this would be operations of vector space. So the operation of vector space, there are four types of operation. They are addition, scalar multiplication, dot product, cross product. The addition is the vector that can be added component wise, allowing for the combination of multiple vector quantity. Scalar multiplication vector can be scaled by scaled values which can be used to adjust their magnitude. Dot product. The dot product of the two vectors represent their project onto each other, revealing information about their relative orientation. Cross product. The cross product of two vectors, generally the vector of the orientation to both useful geometrical and physical, are the things of the operation of the vectors. So there are many type of such other operations, but these are the four things we would be learning in this concept. So the next concept would be applying the Newton's theorem on the vector space. Let's see how to apply the network theorem to the vector space. So the graphic structure, central measurement, community direction. So the vector space can be represented as graphs where the vectors are noded and their relation are adjusted of nectar technology. So, identified by the central vector within the network and reveal the most influent or important elements within the vector space. Community direction. The clustering orthography can be used by identifying the groups of enclosing the related insights, the understanding structure of vector space. So these are the things which we see when we are applying the network theorem to the vector space. So the graph structure is very much important to understand the graphical theorem. In the last, which we studied how the graph can be represented. So the next topic would be the operations. Sorry, the next topic is the optimization techniques in vector space. Linear programming. Optimizing linear programming object linearly can be formatted as a vector space problem within application in source, allocated, and the decision making. The intention optimization can be directed at magnitude of changing with the machine learning and data analysis. Convex optimization explore the convex properties of the vector space application in science, processing, controlling theory, economics. So these are the optimizing techniques that are used in the linear programming or the other things with convex optimization and the gradient descent, and then the linear programming are the things that can be learned easily. So the next topic we'll be learning about the applications of the vector space. So let's see. So the practical application of vector space are of four types. We use it in computer graphing, machine learning, signal processing, quantum mechanics. The computer graphing, the vector space are the fundamentals to the representation and manipulating of 2D and 3D graphs. Enables creation of the realistic and dynamic visual environment. Machine learning vector space provide the mathematical foundation for many machine learning automates, allowing for the efficient process and analysis of higher dimension data. So signal processing, the vector space technique are the employed for various applications such as image audio processing to the external revealing features and pattern. Quantum mechanics, the physics space and the central mathematic are the things. So the conclusion and the future direction are empathy application, interdisciplinary combination. So the vector space continues to find a new application in field like quantum computing, data visualizing, and nervous systems for further advantages. The vector spaces are also collaborating with the maths as well as physics in scientists exploring leaders and the other things. So yeah guys, this is the last topic of the sem 2 maths video assignment. So let me explain about other new videos in the upcoming days. So do like, share, subscribe, comment your opinion on the comment section, and hope you guys like my video. So thank you for watching my video, and do share with your friends and make me reach 60 likes and 200 views, and hope you guys will always support me the same. Thank you.